Hello guys, welcome back. Welcome back to the training. So today we're going to continue where we left off. So let me just run the intro and we can start from there. Okay, don't forget to like and subscribe. It will help the channel to grow and you get notified of our new content. Okay, so in the previous days we covered what Linux is and how to access command line. Today we're going to cover chapter 3, which is called the file system hierarchy and how to manage files on these type of machines. So to do that, I'm going to work with you guys with a screenshot here of a file system, a typical Linux file system. This applies to RHEL or Red Hat Enterprise and applies to pretty much any other Linux with some slightly variants, but for the most part, this is the same thing for most or all Linuxes for the most part. I'm going to look down because that's where the image is. So I'm sorry, I'm not looking at you. So here you can see the typical components of a file system hierarchy. So each folder will have a specific role or will have a reason to exist. This is not, the other operating systems are not different. Other non-Linux operating systems are not that different. They also have a file system type or a file system hierarchy created that will allow the files to be placed in specific locations for specific reasons to exist. Linux is not different. So I'm going to walk you through a typical file system hierarchy. This is basically what all Linuxes use with slight differences, but this is going to be kind of RHEL focused. Not all folders are here. Some folders are not represented in this image, but this is kind of a starting point for the rest of this video series to make a little bit more sense. So typically, a typical Linux file system starts with its folder. It is called the root folder. Okay, this is the root folder. So if you are watching this in your phone, if you turn your video upside down, you will see that this resembles a tree growing from the roots to the leaves. Okay, this is basically what's happening here. The tree is growing from the roots to its leaves. This is not that different. This is a file system that grows or starts in the root, which is where most things grow from, right? So the forward slash means root. Then I'm going to go through these folders that are represented here, not in a specific order, not by order of greatness, just any other will suffice, will be good enough. I mean, you have two folders. You have the bin and you have the S bin. So bin means binary, S bin means system binary. So both of them contains binary executables. No surprises there. So they both contain executables. So, but typically the bin folder contains executables that most or all users can use. Stuff that is basically harmless to the system. S bin uses are binaries used by the admin user or equivalent, the root user or equivalent. So in the S bin folder will contain, or the SBin folder will contain stuff that can actually do changes to the system. Typically, in a broad image, that's how we imagine things. So if I go here to any box here, I'm using I'm sorry, capture is not working, or is it? Oh, it is. I'm stupid. I'm sorry. I thought this was not moving. So yeah, if I go to this box here, top left, and I need to pull this a little bit down there. So if I can for example use the pastelbud utility as an example. So I know where it is, but if you don't know where a specific executable is, you can use the do which command, and with the executable, want to find where it is, and this is going to show where it is. So which will show you the location of executables. So pastelbud it's on USR bin. Okay, why is that? That's because if you look here, there is these dots here. This means that the folders have moved. So if you are using quote unquote older systems, not that old, 5-6 years old maybe, you'll see that it's on a slash bin. If you are using a more recent operating systems, Linux operating systems, now it's on the like you see here, USR bin. That's exactly what you are seeing here. It's not of a big deal. Okay, you just need to find where it is, and it's the same as executable, just a new path, but it means exactly the same thing. So it says, as you can see, the possibility command, it's on the bin folder. So it means that all or most of regular use can use it, which is true. We saw this on a previous video. Now, if I do, for example, the IP command, which is related to network configuration, you will see that it's on the S bin. So this is anyone can use, only admins can use. So there are exceptions to this rule. Of course, there are always exceptions to all rules. But basically that's being regular users as being system user. Okay, so without going through exceptions, which is would be time consuming, and we will find them as we go along. Being regular users as being admins, and the which utility will show you the path to executables. It's an easy way to find where an executable is, which is its full path. Okay, going back here. Now we have the /boot folder. The /boot folder is where the boot files are contained. Again, I'm sure you guys could figure this out on your own. The dev folder is a special folder. This folder, remember on a previous video, I said in Linux, everything is a file. So hardware components are represented by files on the dev folder. So it's not a folder we usually tamper with. It's not a folder we usually touch or do admin stuff in there. There are exceptions, of course. There are always exceptions, but the rule is the dev folder, I will not tamper with the dev folder. It just stays there, it lives there, and it will leave it there. The system needs it to work. The etc folder, it's typically where we find configuration files. For example, we will come across this throughout the week, throughout the video series. We will, for example, if I want to configure HTTP or any other service or of that kind, easily on the etc file folder, we'll find a file that configures that. For example, we can see the etc possibility file, text file that will contain the configuration files for user accounts. Home folder means that every user has a home folder. Okay, so if I go back to here to any system, if I do the pwd command, the pwd command will show me which folder I am currently on. And this is showing me that I'm currently on the home student folder. Okay, so if I was a different user, we will create new users in a future video. If you create a user called Alice, for example, it will have a home Alice folder and so on and so forth. So it's where people have their files and their folders on their own home folder. So it's like their corner to store files at their leisure. Okay. Again, if you look here, the tilde means home folder. So if I go to DTC folder and I get out of my home folder, if I do cd tilde, this will bring me back to my home folder. Okay. So tilde is kind of a universal meaning of home folder. Okay, that's why it shows tilde here and not a full path, because for the bash terminal, tilde means home. Okay, so this is normal. This will actually mean this and vice versa. Okay, so everybody's entitled to a home folder with one exception. The root user has his home folder on different location. So it's /root, not /home name. Okay, that's something to be aware of. That the root user has its own folder too, but it's not on home something, it's /root. Okay, so that's something to be aware of. You have the /run folder. The /run folder is a folder that is called runtime. Okay, runtime means that everything that is stored on this folder, it's going to be deleted on next reboot. There are some exceptions, but let's not dive into that just now. Just imagine that the run folder, when every time you reboot the server, the contents are deleted and rebuilt from fresh. The SBin, we know what it is. You have the TMP folder. The TMP folder, it's used to store temporary files. So something for the system to keep running, like you install a new package or something, it will use a temp folder to store some files. You have the USR folder, which contains the following folders: the bin, now you know, the S bin that you know, local is like everything goes there, like install a browser, local files will go stored there. You also have the temp folder, another temp folder on the USR folder. And you have the so you used to have a var temp folder. Another var temp folder is on USR temp. Again, you don't have to worry all that much about these exceptions, because it's not something you need to actually know. You just feel it and you, oh yeah, I remember this. It's fine. And with in time you actually have time to memorize this. Then you have the var folder. Var means variable data. For example, websites, FTP sites, the log files are on a var folder. So this was kind of a broad overview. What I recommend you guys to do is get the system and explore yourself the contents of the folders and get yourself acquainted with the folder contents, or just use the system as normal. And in time, you will get yourself, well, with experience and with the system use, you will in the end get yourself acquainted and you know where everything is. So no, it's not a big deal. Now, one thing to understand here, or understand too, is the following. When we are working with these type of systems, there are two types of paths. They call it the absolute path, absolute path, and the relative path. What is the absolute path? The absolute path always starts with a slash. For example, the absolute path for the etc bin passwd. Oh, I'm sorry. So the absolute path for the passwd utility, it's usr bin passwd. So this is kind of the full path starting with a slash. Okay, so this is the full path to get to the passwd executable. The absolute path, it starts with a dash. It always starts with the root file system. It's kind of the absolute beginning of the path to a file or folder. Relative, it's relative because it depends on where you are. So let's say, let's find out where I am. I am on my home folder. So my relative path to get to the passwd, it's a little bit longer and more cumbersome. So it means that I have to go back to the home, back to the slash. How do I do that? cd dot dot. Dot dot will put me a level above. cd dot dot, I'm on the root file system now. Now I have to go to the USR, I have to go to the bin, and I go to and now finally I can find the passwd utility. Okay? So absolute path names always start with the root file system. Relative are called relative because it depend on where is my starting point. So for example, let's still use passwd as a reference. So if I start with var, okay. Now to go to the passwd executable, I need to go to the root, go to the USR, go to the bin, and then I find my passwd utility here. So absolute path names are usually, for the most part, are always the same, which means that, I'm sorry, I mistyped it. Okay, so the absolute path for the passwd executable, it's always the same, never changes, because it's always going to be this, it will never vary. Relative will depend, it's called relative because depends on my starting point. Is if I'm here, to go to the passwd, I have to go back a few levels and up a few levels. If I start with the var, same thing, but relative depends on where I start. Absolute, it's always the same. The absolute path name never changes. Okay, the absolute path never changes. Okay, so I do prefer to use the absolute path, and I don't. Well, it depends on the situation, but this one is kind of it kind of never changes, so it's kind of a certain thing, right? Relative, it's relative, so it will depend on where you start. I do prefer to use absolute path names because I'm forgetful and I get distracted really easily. So it's better to me to use absolute path names because they just never change. So they're more predictable, and it helps to my child's brain to work better. Okay, a few more commands that can help us to navigate a file system. You saw the cd. If I type cd enter, let's say, for example, I go here, I type cd enter, this will take me immediately to my home folder. So it's kind of a good shortcut to get out of where you are. CD home folder, it's kind of always the same thing. CD, it allows you to navigate throughout the file system. So CD means change directory. Other utilities that you can use are, for example, mkdir. This will allow to create a new directory. You just need to be sure that you have permissions to write on the directory. And since I am on my home folder, that's okay. That's a given. Okay. rmdir removes the directory if empty. So if the directory is empty, rmdir will remove the directory. So mk it's make, rm it remove, and usually this applies to most things inside a Linux box. mk creates, rm removes. That's kind of a standard thing to assume. Okay. Now, if the directory is not empty, so let's create a directory. Let's go inside it. It's currently empty, apparently. Of course, it is. I just created the folder. Let's create a file there. So there are many ways to create files, but let me show you the touch file, the touch utility. So the touch utility that you probably saw beforehand allows us to create files, create empty files. Okay, let's call it empty. Okay, this is a file that it just exists, but it's empty. It's a text file that is empty. Okay, let's try and check this out. Okay, so basically it's absolutely nothing. If I catch the file, it's empty, but it's a 0 bytes file, like you can see there. So it's a 0 bytes file, and it's an empty file. Okay, so it just exists. So what is the usefulness of the touch utility? So the touch utility has, I would say, multiple use cases. Let's say that one is this one. So if you touch a file that does not exist, it then exists but empty. Okay, it just exists. It just exists for the world to see. Okay, it's not having a specific use case to exist. It just does. Okay, then you can just do whatever you like with it. Another case, which is kind of the original use case for the touch utility, it's the following. So if I do the ls-l, which is a long list will allow me to see the details about the file. You will see that in this case, it was created at 9 a.m. 55 minutes. Okay. If I touch it again, so if it already exists, you will see that now it has its timestamp updated. Okay. So if you touch a file that already exists, it will update its last change to now or to a specific date. So if you do touch --help, like we saw beforehand, you'll see that you can specify the specific time or date with the timestamp option. But if you don't, if you touch a file that already exists, it will update its timestamp to now, basically. If you touch a file that does not exist, it's created with empty contents, unless you go to the help, you'll see that it has a no creates option. So if you do touch -c no create, for example, the file does not exist but was not created. So by default, if you touch a file that does not exist, it gets created. Okay. If you touch a file that exists, it changes the timestamp to now or to a specific time and date that you specify. However, you can use the -c, and the -c will allow you to do not create the file if it does not exist. So it's kind of a multi-use case utility that you can use in many different situations, and we will use it throughout this video series. However, now the directory is not empty. So if I go back, if I try again the same utility, it will not remove it because it's not empty. So the rmd will remove directories if empty. If not, I have to use the rm command, and use this rm command very carefully, especially if you are the admin user, because this can create great harm to your system. So if I do rm directory, it's going to tell me that it cannot remove directory because it's a directory and it's not empty. So I can be very aggressive and do this rf. Okay, this is going to remove the directory and all its contents. So this is remove without any regard of anything else, and f is force. So remove forcefully this directory. This will remove the directory and its contents. So use this action very, very carefully. Okay? Use the RM minus RF action very carefully, because this is going to remove the contents of a directory itself in a very aggressive manner. And if you are an administrator, you can even remove things that can be system relevant. Okay, so use this very carefully, the RF option, because this can be very aggressive and can delete things without you. As you saw, it did not offer any confirmation. So use it carefully, and if you are using the root user or any equivalent user, make sure to make sure to read the command multiple times and make sure that you are doing what you actually wanted to do and you're not doing anything that can harm your system in a very serious manner. Okay? Now, I can also create mkdir directory and a subdirectory like sub1. This will not, I did a typo. This is going to create the directory. That's not what I wanted. Let's create this again. As you can see, it's not creating kind of a hierarchy. So if I want to create one within the other, you do mkdir minus p, you do dir 1, d2, d3. Okay, and now this is going to create. I'm so stupid. I'm using the wrong slashes. It's nice for you guys to see me doing mistakes. That's how you learn too. So let's do this again. I'm using the backslash and not the forward slash. So mkdir, let's do this. Let's do the directory /dir2. This is not going to create because I cannot create dir2 within a directory that does not exist. So the directory called directory does not exist. So there is no directory called directory. So I cannot create dir2 within this one, because if this one does not exist, how can I create this one? That's when the -p come into play. This is going to create this one and then the next one, or however many you wish. It's a good thing I did this mistake, because you can see what I just said. When you do the rm command, make sure that you are looking at the command with attention, with detail, because I could make a big mistake if I was not noticing that I was using the backslash and not the forward slash, because on Linux it's a forward slash that you need to use. So you saw me doing a mistake. Good thing you learned with me that you should really read multiple times what you are doing before you do it. Like, to end this topic, let's just, well, not now, but this subtopic, let's discuss the cp command and the mv command. Okay, they are quite simple. Cp command, it's a copy command, and the mv command is the move command. Okay, so I don't think it's needed to show, but I will do it anyways. So I will do the touch, let's call it file1. If I do cp file1 to the red directory, it copied the file to there. So I don't think nobody's getting really surprised with this. If I substitute TCP by MV, it will move the file, it will disappear from its source, and it was placed on the destination directory. So copy will create a copy, move will move. We will delete the source and put it on some directory destination. So pretty simple. So these copies, these moves, I think at this point everybody knows the difference between the copy and the move, but I will say it anyways. So copy will create a new instance of the file. It will copy it. Okay, you will keep the original and create replica. Move will make the source disappear and make it appear only on the destination directory. Again, use the move command carefully, because you may move things that well, it can be, when misused, can create problems that you really don't want to face. Okay, cool. Now I advise you to get a system and get acquainted with the move and the CP, especially with the -R, which is recursive. This will copy all files and folders and subfolders, or move or delete. So be careful with the R. It can be capital R or lowercase r. It depends on the command. Also get acquainted with the -V option, which means verbose. So verbose means give details. Oops. Okay. So usually some commands are silent, so which means that they'll do what they have to do without without giving any feedback to the screen, unless you do the -V, which is verbose, and this will allow you to see more details on the screen while the command is doing its things. But explore the -- help of each command now that you know what they do in a kind of a greater perspective, and get yourself acquainted with the switches that you might use more frequently. Okay, cool. Let's finish this chapter up with something really cool, which is links. Okay, so let's talk about two types of links. Let's talk about, let's talk about soft links. Okay, and hard links. Oh, let me give you some space. Okay, so what is the difference between the soft link and a hard link? Let's start with soft link, just because, yes, no special reason to start with soft link. I could start with the hard link, which will be just fine, but let's start with soft link. So if you are familiar with the Windows shortcut, if you know what the Windows shortcut is, that's basically what the soft link is. So let's jump into the terminal here. Here we go. So let's just clean house. So let's do on rm -rf d2 this one. I don't want this one. Directly sub one. I don't want this one. Let's delete the D1, blah 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 blah, and let's play with the directory. Let's play with this one. Okay, so I have here a file called file1. Okay, I have this file here, and let's give it some content. I don't want to use a text editor just yet. I'm going to use a technique called the redirection. So I'm going to do this. I'm going to do echo. If I do this, is just going to type to the screen what I just typed. But if I do this, the greater than sign and to the file, this is going to redirect inside that file. Okay, in a way, I have just edited the contents of that file. So I added the hi message to the file, which is a text file now. Okay, so doing this on its own, it will put it to the screen. If I do like this, it will redirect from the screen to the file. Cool, eh? Very nice. Just be careful that by doing this, it will completely replace the contents of the file. If you want to add, you do like this. Sorry. Okay. If I use one bigger than, it's going to completely replace the contents of the file. All right. Cool. So the file has something inside. It's not just an empty set file. Okay. Now let's say this file, I want to access this file not only through this folder, but I want to create a shortcut on some other place. So I can do, if I don't do this at first try, just bear with me because I sometimes have to do this twice. So let's do this. ln creates links, soft and hard. -s is soft link. Again, nobody's surprised with this, I'm sure. So let's say I wanted to create a link to this file on the var folder, and it's called file link. And it links to the home student directory file1. Okay, it's the other way around. That's fine. Like I said, I never do this at first try with success, but it's fine. I just can read permission denied. Okay, I cannot, as a regular user, I cannot write to the var folder, which makes sense. So I'll just put the link on my home student folder that I can write. Not homes. Okay, students, and I call file link. You have to be able to write on the destination folder. Cool. Now, if I go back to my home folder, you see that's a file link. If I do a long list with ls-l, which is long listing with the details, you'll see that this points to there. So if I do a cat to this, there we go. See? So basically this is, if you look here at this first character, you'll see an L. Okay, and L means link, okay, which means that this file points to that one. So if I read out or write from here, I'm actually reading or writing to there. So if I do echo hi to bigger bird, I can cat and the contents are changed. If I go to the original location with the original file, you'll see that the contents have changed. So soft link is a shortcut, and you can soft link anything, files, folders, whatever you like. That's what is happening if I go here to the root file system. You'll see that the smin is actually a soft link to that new location, like you saw in the screenshot. So basically they are soft links. So this points to there, and the bin points to there. So that's why I don't have to, like I said a few minutes ago, you don't have to memorize that stuff. Just let it happen, and you will naturally understand and internalize all that information in due time. So it's all good. Now, if you go to the hard links, so hard links can be a very long matter to discuss, but I will keep it very, very simple. So let's say hard links are alternate names. Alternate names. Let's try to write this, alternate names. Okay, it's a different name to the same file. Okay, so if I go back here, and of course this can be a very long discussion. Hard links can be a very long discussion, but I will keep it really, really, really simple. So if I go back to the directory, to the file we were discussing right now, okay. So this file, it's on identity. If I go back to if I list the shortcut, oops, I'm sorry. You will see that the shortcut points to that one. So this is a file, completely new file with a special behavior that can actually point to a different file. Okay, so this one is kind of an arrow pointing to that file, which is kind of what you see here. Okay, if I look to the original file, this file here, it's kind of its own thing. So if I add here this option, which is the I stands for inode number. Long discussion, I will not go through this here, but the inode number, it's this number here, and this is a system-wide number that represents an ID of this file. It's like our identity card, okay? So this is the number that represents this file, okay? If I look to our arrow, the soft link, also using the I option, you will see that it has a different number. So each file has this ID, unless, so this is the ID of the original file, okay? Now, a soft link is an arrow that points. It's a new file that points to another file or folder. A hard link, it's an alternate name. So let's do this. So let's immediately do an example. ln, let's call it file1 hard. Again, if I mistake, do this in the other way around. That's just me. Okay, it's the other way around. I never do this right first time. I don't know why. If I go back to our original file, you see many differences. You see that this file still has its same ID, which makes sense, but this number changed. It's now from 1 to 2. It means that this file now has an alternate name, which it does because we just created it. So this is the original file. That's called original because it was the one I created first. And this is the hard link. So this one, okay, and this one, if you check here, they share the same inode number. So they basically are the same file, but with two different names. Now, if I can just, let's try this again. Let's do this the other way around now. And let's call it file hard 2. If I go back to this option, as you can see, all three are the same file, but they have different names. Okay? Which means that if I change one, let's call it hard, for example, and go to file 1. Let's say hard 2 and go to file 1 hard 2. I can just check the one that I did not change. So I redirect it to this, then to this. But if I check this, it will have the changes. Okay, because they are the same file. They are exactly the same file. Same file with 3 names, same file with 3 names, same file with 3 names. So it's just an alternate name to the same file. So it's to most applications and services, we are looking at the same file with different names. So one is a shortcut, one points to the other, and you can shortcut files, folders, whatever you like. Hard links can only be done to files, not to folders. And basically they are the same file with different names. Same file, same file, same file, different name, different name, different name. Which means that if I delete this one, which is the first one that existed, everything is fine because the other two still exist. Okay? Okay? I can delete the second instance just fine because this one still exists. Now we are on danger zone, which means that I have the single instance of the file now shown, which means that if I delete this one, file is gone forever. But I can just create a replica, not a replica, an alternate name to the same file. So let's call it file 1 hard 2 to file 1 final. I don't know. My imagination is kind of running out. Yeah. So now I have 2 instances of the 2 names for the same file. I cannot, remember this, I cannot link folders. That's impossible. You cannot do it. But files you can. And I'm doing this on the same, they are both on the same folder, but I could just do something like home, student, final 2, and it's there, final 2, and final 2 is here. You check the inode, this inode 993 checks with this one, which means that this alternate name for the file, now it's on a different folder. So it's just a way to can scatter alternate names for the same file, for the same content. So if I do echo final, whatever, to this one here, if I go to the one that has the other ones, they will have the change applied to. Okay, so hard links are alternate names for the same file, and soft links are shortcuts. So on hard links, you can delete all the replicas until you have only one replica, and then you will delete the whole file. But as you can see here, I have 2 hard links, but there is one missing. I know where it is. It's here. So I know that it's here. But if you see this, you see that 2 are here. A third one is somewhere on a file system. There are ways to find it. We'll see that in later videos. But for now, if you see 3, but you see the number 3 there, but you will have only 2 instances in front of you, there is a third instance somewhere in the file system that you need to find. Let's disregard the directories because the directories are a completely different beast. I'm talking about files only. Well, it was quite of a long video, but it was quite nice. Like and subscribe, it really helps. I will post more videos as fast as I can about this subject. Hope you liked it. Type down below on the comments any questions you may have. I'm happy to answer them. I'll see you in the next video. Don't forget, like and subscribe, it really helps. And I'll see you in the next one. Cheers, guys.